As we close out the pre-calc book, we really have very limited new information here, and I think you're going to understand really the only different idea. The first thing we're going to do, which is what's unique, is we're going to find what is the actual equation of that tangent line. Do you remember what we said? The derivative is the slope at the tangent at any particular place. So a derivative is the instantaneous rate of change, but that's a slope. They're the same thing. So when we find a derivative at a particular point, we found the slope. Now what we're going to say is, well, what's the equation of the entire line? Now, it's actually not very hard. So let's look at it here. I've got this function, and they want the actual equation for a line. So we're going to do, so they've done the long version, but remember my shortcut for a polynomial. The derivative here is going to be 2x minus 4. So do all this work by the definition, and it's really that simple. So here we go. The derivative is 2x minus 4. We want to find the derivative at that point. So when we put 3 in there, they've done it for us here. You put 3 in, you get out 2. Okay, this is the slope of the line. Okay, well, we have a slope. Well, I could make this line using the point slope formula. If I simply had one point that's on this line, well, we have one. We know at the place that we're making this tangent, we know that's a point on the line. At the point 3, so let's put 3 into the original equation, we'd get 9 minus 12, we'd get negative 3. You see what I've done? This is just a point on the line. 3, negative 3. Did I do it right? 9 minus 12. Yeah. So this is a point on the line. So I found the derivative at a particular point. That is the slope of the tangent line. So it's 2. Now I have a point that's on this new tangent line. That's the point we were checking. When x was 3, y is negative 3. I just put it in the formula. That's a point in the equation. So y minus negative 3 would get me, so y minus this y point, x minus the x point, and I can make the line. That's all. There's a formula earlier, but that's all we're doing. So y plus 3 is 2x minus 6. Y would then be 2x minus 9, and there it is. I've got it. So all we're doing, find the slope, use the point that's from the location you're at, 3, in this case 3, negative 3, and find the line. And so we found the equation to be of that whole tangent line. So the slope was the 2, but we found the whole equation just by using point slope. Using this point, using the slope we found, and we got it. So pause it if you want to try this on your own. You may want to practice using the definition of a limit, but I'm going to just go ahead and do the fast version because it's a polynomial, nice and easy. This is going to be 10x, so the 2 times the 5, kick this down 1. This is got a 1 exponent, negative 1 times 1 is negative 1. Then the x drops down a degree, which means it's just going to turn into a 1. The 4 drops off. So this is my derivative. So let's find that instantaneous rate of change at this point. It's going to be 20 minus 1 is going to be 19. Okay, so there's my slope. So now let's just find the whole equation for the tangent line. It's just the point slope formula. That's it. I've got a slope. Now I need a point. Well, we've got a point. Let's put f of 2. Let's put 2 into the original equation. So this is 4. We get 20 minus 2 plus 4. I get 22. Okay, so we have a point. We have 222. So that's all we got to do. All the way back to like when you're first learning about lines. So solve this. Got 19x minus 38. So I'm sending the 22 to the other side. What am I going to get? Negative 16. Okay, as long as I didn't do that too fast, there's the equation for the tangent line. All right, we've seen this as well too. What we saw is that instantaneous velocity. We saw this in the last video. If you have, this is distance, so a function based on s, that's our terminology for distance. If we take the derivative, the instantaneous rate of change for distance turns out to be velocity. That's it. It's the instantaneous velocity. They're synonyms. This is nothing more than the definition of a derivative. And so this is instantaneous velocity. It's nothing we haven't seen already. We've literally done questions like this before too. They want the instantaneous velocity. Well, we did this in the last video. So they're doing this by the definition, but we could have jumped ahead. So remember what we could have done here. We'd get a derivative of negative 32t plus 36. And there it is. A little bit faster than what they did. Okay, now we would just put in t. We want the instantaneous velocity when time is 2. Just put t into that, or 2 into that, and it crunches down to be negative 28. And there it is. So it's dropping because we have that negative there. So the rate of change is 28 feet per second, but we're going down because it's a negative. Okay, pause this if you want to try it on your own. But I'm going to go ahead and start, and I'm not going to do the definition. I'm going to do the fast version. So t's are difficult, but there's my definition, or there's my derivative. Now we want to find it at 4 seconds. So I'm finding what happens when you put 4 in there. Okay, it's been a long day of videos, so I don't want to do any math in my head. So I'm going to do my calculator. So I've got 60 minus 128. All right, so I get an instantaneous velocity of negative 68. Okay, so this is a speed. So this is feet per second, downward because of the negative. All right, really not a lot new there. Just all we'd have to do if we wanted to find the equation for the entire tangent line is we find the derivative at that point. That's a slope. And then just use the point slope formula. And the point that we have is the x and y for the place where our tangent line is hitting the graph. So hopefully that makes sense.